Today we're going to be making iodine. So iodine is a black solid, and as you can see its molecular weight is, or rather the atomic weight is this, and the proton and electron number is this. Its electronegativity is 2.2, melting point fair lower, and the boiling point. And iodine normally sublimes at room temperature, and sublimation means the transaction from solid to directly to gas. This is known as sublimation. So let me show you what iodine looks like. Now I just poured some iodine out, and as you can see it's focus. God damn it, wait. As you can see it's really dark, almost black. I would say black, but it's really dark purple, and as you can see it's already staining my page. It's everywhere, and it's in a vial, and iodine is really dense. Iodine is really dense, as you can see from its molecular weight or atomic weight, I don't know. So this much is almost 14 grams. Okay, let me put all this back. Now, as you can see, the iodine just stained almost everything from here and down to here. So iodine is on the 7th of the periodic table, or the 17, well, whatever. So it's on the 7th group, known as the halogen family, where the normally in periodic table on this side, as you can see from on the alkaline metal side, reactivity increases as you go down. So lithium is least reactive than sodium is least reactive than potassium. But on the halogen side, as you go down, the reactivity decreases. So fluorine is more reactive than chlorine, and chlorine is more reactive than bromine, and bromine is more reactive than iodine. So and as you can see, iodine is right there. Iodine electronic configurations, and well, its oxidation states, I don't know. Well, so, and every halogen has 1 electrons on their outer shell, which makes them reactive enough. So iodine is the least reactive from all the halogens, apart from astatine. Okay, so iodine is also poisonous as all of the halogens like bromine, chlorine, and fluorine. So, well, iodine. To make iodine, you're gonna need potassium iodide, dilute sulfuric acid, and it does not matter if it's 20%, 10%, or may even 50%, but try to get the lowest concentration. Over 10% and less than let's say less than 40%. Yeah, more than 10%, less than 40%. Okay, so you can use 98% sulfuric acid, but it's gonna be really messy and you're gonna need less stuff. I'm gonna show you on my way. So sulfuric acid, dilute sulfuric acid, and some hydrogen peroxide. Now hydrogen peroxide can be of any concentration, 3, 10, 35. So the trick, what can I say, the point of using higher concentration of peroxide is that you're going to use less liquid, so it's going to be like less messy, I guess. Okay, and using a lower concentration peroxide would result in using more Now I don't know how much percent this is, but I'm pretty sure it's around 4.125 molar per dm cube. So peroxide and some usual glasswares, lab glasswares. So here I've done all my calculations, and yeah, if you want to look at it, you can pause now and sure. Okay, so I'm gonna explain what's happening here. So Ki, or the potassium iodide, is reacting with sulfuric acid to form potassium sulfate or potassium bisulfate and hydroiodic acid. Now hydroiodic acid is our target. So hydroiodic acid is then oxidized using, where is it? Hydroiodic acid is then oxidized using hydrogen peroxide to obtain iodine and water. So instead of hydrogen peroxide, you can use potassium chlorate or potassium permanganate or nitric acid. Now, for my purpose, I'm gonna use 5 grams of potassium iodide. Here I've measured some out on this plastic paper, plastic cup or whatever. Okay, so 5 grams. Now, as you can see, it's fluctuating because I got the fan on and it's interrupting the measurement. Okay, so I measured out 5 grams, approximately 5 grams of potassium iodide, and then I measured out about how much? 1, 2, 3. Okay, 1, 2, 3, 4, 5, 6. Okay, so 6.6 milliliters of hydrogen peroxide and sulfuric acid, around 20 milliliters. Now peroxide and the sulfuric acid are in a huge stoichiometric excess, so you can get away with using less of the thing. Well, I can't speak today. So sulfuric acid, hydrogen peroxide, and potassium iodide. Now just to show you, so just to show you what happens if you add concentrated sulfuric acid. So here I have potassium iodide and here I have sulfuric acid, concentrated sulfuric acid. So add in solution and okay, that should not happen. Oh no, okay, wait. I added less and no. So you can see it getting brown and browner. Okay, we're gonna mix it. So apparently my sulfuric acid is not concentrated enough. Well, so here we have some iodine suspended, or well, we don't have anything. We just have hydroiodic solution and potassium sulfate solution. So what happens if you add concentrated 98% sulfuric acid? You'll still ask. So what happens is iodine directly comes out of the solution and I can feel it, it's exothermic, and this reaction is also exothermic, the adding 98% sulfuric acid. So it directly precipitates out, so you don't need to add hydrogen peroxide. But it's really messy. Fumes will what do you call it again? Yeah, iodine fumes are gonna just escape, gonna fill your whole lab or maybe even your house, gonna sting your nose and other bad stuff. So well, it's better to do in this method, like potassium iodide, sulfuric acid, and hydrogen peroxide. Okay. Now to this iodide, I'm gonna add around 15 milliliters of water just to make a solution. And my flask was dirty and I got some hydrogen peroxide in it, so that's not good. Okay, we're gonna swirl it and we're gonna dissolve all of it, and I'm gonna come back when it's all done. Okay, so now all of it has dissolved, and if you have every glassware cleaned, then you should not get this yellow color. Instead, you should get a clear color. Okay, now we're gonna add this sulfuric acid, and remember to wear gloves, and I'm out of gloves, so I'm not wearing any. So we're gonna slowly add it. Oh, what the heck. Okay, so again swirl it, and here we have our hydriodic and potassium iodide solution, potassium sulfate solution. And now we're gonna add 6.6 milliliters of hydrogen peroxide. 3, 2, 1. And as you can see, the color change is pretty evident. And now you wanna swirl it and find a watch glass around. There we go, and just put it on top. There we go. And sooner or later you should see purple vapors filling the whole apparatus, and the solution has gone really blood red, brownish. So we have successfully oxidized hydriodic acid to produce water and hydrogen iodine. So iodine is not in the solution right now. It's perfectly clear. Iodine is not really soluble in water, so it should precipitate out. So we're gonna give it a time. We're gonna leave it. Wow, it's really red actually. It's like blood. Okay, so we're gonna give it some time to settle. It's hot too, so not too hot actually. Oh well. So it should precipitate out, and I'm gonna come back when it's all done. Okay. And now to the iodine hydriodic solution in the test tube, I'm gonna add some nitric acid to oxidize the iodine out. So 3, 2, 1, there we go. Oh, okay. That's similar to, well, sulfuric acid, and the iodine actually it precipitates out really fast. Immediately you can see iodine precipitate out, and the reaction is exothermic, and the black stuff that you see is actually iodine. And yeah, there we go. So except of hydrogen peroxide, you can also use nitric acid. Good. And we're gonna give this more time. Well, I'm gonna come back later. Okay, so this is taking really long time to precipitate out, so I'm gonna continue the second part in, well, the second part. I'm gonna continue this stuff in the second part. Wow, I can't speak. Okay, so the other thing I see is when I shine light on the other side of the beaker, I can see purple color. Okay, so to the nitric acid one, we can see a lot iodine just precipitated out from the small amount of solution. Okay, and my camera is not focusing. Okay, so there's one thing to keep in mind, that nitric acid is a really strong oxidizer, and it might even oxidize the iodine to iodate. So you should keep it cold and filter out the iodine as fast as you can. So I'm gonna do that, and I'm gonna continue the whole thing in the second part. Bye.